So basically for tonight, we'll talk about recursion and we'll talk about lambda. Then tomorrow, I think we'll finish with classes and objects, the OOP, we'll talk about object-oriented programming, basically looking at the classes and objects and how they are defined and all that. So today we'll talk about recursion. And as I had told you earlier, recursion simply means that a function is calling itself. And so far by now, you people are now seeing how recursion works because we've tackled two instances where we saw recursion being implemented. The first one was the Fibonacci sequence, and also we looked at the binary search where we were able to see how a function calls itself recursively. So basically, if you want to implement the recursive algorithm, or you want to know if something like is being like referred to as its recursion or it's occurring recursively, so for you to write an algorithm, or if you want to implement any algorithm, you must keep in mind that you are focusing on two cases that needs to be in the algorithm. The first one is the base case, and the second one is the recursive case. So every time, if the function calls itself, automatically they'll reach a point whereby it's going to the it will be infinite. So there will be no end. So it can go on and go on and go on. And that's why this gives us the need to introduce a base case, because sometimes, let's say maybe you're looking at maybe numbers, you're trying to call numbers recursively, maybe say the numbers, you count numbers 5 and below, or you want to count numbers from 5 onwards. If you don't provide a base case, the Python program will just run the numbers and it will reach a Stack Overflow whereby there'll be an error because it will count and even reach to millions. So you need to have a base case whereby it will be referring to it. And if in any case your algorithm is running, when it reaches and it satisfies the base case, then it stops the recursion, like it terminates. Okay, so it means simply that for termination to happen, it means that you need to have some base case. So basically, a base case acts as a terminator, like a condition where the recursion ends or stops. But the recursive case comes in whereby you keep calling on the function, like the function not calling on the function keeps calling itself. So it will always call itself as it gradually moves towards the base. So when it gradually moves towards the base case that you had initiated earlier, then the recursion stops. Yeah, so that is all about the recursion function. So I think we can look at an example. I'm trying to look which example will we use. So I think we can use the factorial example just to illustrate it. The factorial example. So before I go on and I implement the code, we know that if you have an n factorial, what does it mean? It means it's n times n minus 1 times n minus 2, then times n minus 3. Then this will go on until you reach 1, right? So basically, let's say if you have 5 factorial, that means you'll have...
Sorry, Linda, you've written n minus 1 times n minus 1.
Oh, thank you. So it must be n minus 2. Thank you so much. Okay, so for example, let's say we want to do 5 factorial. That means it will do 5, which is n, then times, what will be the next one? It will be 5 minus 1, then 5 minus 2, 5 minus 3, 5 minus 4, then it ends 1. But you can write it as 5, then 4 factorial. Then you can go ahead and write the same thing as, I want us to write like it's narrowing down. The same thing, you can write it as 5, then times 4, then times 3 factorial. Again, you can write it as 5. Let me make this to be a markdown. Yeah, this is better. So the next one will be 5 times 4 times 3 times 2 factorial. Then the last one will be 5 factorial will be 5 times 4 times 3 times 2, then times 1, and 1 factorial is just times 1, and 1 factorial is just like 1. So that is like, this is an example of a recursion, and I just wanted you to understand like mathematically the way we did last time Fibonacci. For you to understand how it works, you have to know how Fibonacci works. So I wanted to illustrate how the factorial works. So the factorial, the formula is n minus 1. So you go as you go on, it deducts minus 1. As you move by minus 1 until it reaches 1. Okay. So basically, we can clearly see that from here, if you try to check, 5 factorial is 5 and 5 is n. Then this 4 is n minus 1. You see? Then 5 factorial is 5, then this 4 is n minus 1, the 3 is n minus 2, and so on and so on. So let's say you have n minus 1, n minus 1 factorial. Who will give me how it will showcase itself? Like, how will it narrow down? Anybody wanna try? What is n minus 1 factorial?
4 factorial.
No, now don't replace the n. I want you to simplify it further.
n minus 2.
Yes.
Factorial.
N minus
2 factorial.
Then
n minus 3 factorial.
does it start from n? It starts from n minus 1 factorial. But now it will not have a factorial. It will just be n minus 1, n minus 2, n minus 3 times n minus 4 times n minus 5. You see that? So it will be n minus 2. Now this is math. Because if you don't do this, then you'll not understand that part of why it's doing recursion, that part. So n minus 4, and it will go on. So look at this formula here. You have n factorial is equals to n multiplied by n minus 1 times n minus 2 times n minus 3 all the way up to 1. So I want you to stand here where I've written n, then multiply by, and then look at this all part. This all part, n minus 1, n minus 2, all n minus 3, all throughout. is it the same as this one, n minus 1, n minus 2, n minus 3, all the way to 1? Is it the same?
Yes.
Hello, are you people lost?
Yes, the same.
It's the same. So basically, what will be our n factorial? It will be n, then multiply by, you replace these one, n minus 1 times n minus 2 times n minus 3, replace with n minus 1 factorial. Yeah. So it's n. Then, if you're lost, don't feel shy to ask. Just ask. But here, this is math. This is math, but we need to understand how factorial works, like how it's going. So that means, you see, like, for example, if you have 5 factorial, that means when you move, it's calling it, like, it's going recursively, like it's something like it's repeating itself. You see, 5 times 4, 5 times 4 times 3, 5 times 4 times 3 times 2, 5 times, like that, as it goes. So from there, you can now come and write our recursion. Now our recursion, the recursion now implementation of this factorial. After knowing how it's working now, if you get, even if it was 6, it will be 6 times 5 factorial, then 6 times 5 times 4 factorial, and then 6, like that, as we move down. So that means that we can go on and go on until you reach the base case, and the base case is always 1. So definitely, if you want to write the implementation, we can factorial, or let me just write fact because of spellings. So you want to look, if, like, you want to check, like, to call the function recursively. So we need to have a base case, and definitely we are seeing that as you do the factorial from 5, at the end of the day, you'll always end up to 1. So you can equate, maybe you say, if, let's say, n then is equals to 1, then we can return, what can we return? We can return 1, right? Else, return n times fact n minus 1. So that is it. So this part is the recursion part. Like, it keeps on calling until when you'll get n is equals to 1. Anybody who is confused? Because any time you get, let's say, n is equals to 1, that means that the function will calculate the factorial by multiplying the n times the factorial of n minus 1. And that is the recursive step. Then it goes ahead. If it again finds that the n value is not equals to 1, it again calls itself. It calls itself until when it reaches the base. Then it stops now. It stops, and then now it executes the output. Okay, who has a question? Any question? Okay, I think you people, you are tired. So let's try now. Try on, let's say, fib 5. Are you people tired?
Is it fib or fact?
No, we are not tired.
Yeah, that's why I want you people to talk. Because I'm just writing and writing and writing. Yeah. So you see, the factorial of 5 is usually 120. So what happens is that this function is, it keeps on calling itself until it reaches 1. You see? So I think maybe if you need more explanation, maybe you can tell me to maybe do on a markdown, or if you're okay, we can continue. Are you people satisfied?
That's okay.
It's okay.
Linda,
Yes.
must you assign that that function fact into a variable known as result?
No, you can do it whichever way, so long as you can do whichever way, so long as you get the 120. You can decide to give it a variable, or you can just go ahead and maybe call the function. It doesn't matter.
Okay, thank you.
Yeah, so long as you get it.
Linda, please, can you just go through it again? I just came. Sorry to draw you back. Just the
Okay.
explanation.
Okay, so basically we are saying that a factorial, like looking for a factorial of any number, it's an example of a recursion. And we've tried to look at how somebody can write we have tried here to look at how you can calculate the factorial of a number. And from our mathematics point of view, I know you people read it in your secondary schools or higher education. So you get, like, for n factorial, it's usually n, then multiplied by n minus 1, then multiplied by n minus 2, n minus 3, until you reach 1. So let's say for 5 factorial, you can write 5 factorial times 4 factorial, then you can times 3 factorial times 2 factorial times 1 factorial. But something that is making me write for you like this is because this computer, like when the computer is running like the Python program, you see, it cannot just go ahead and do 5 times 4 times 3 times 2 times 1. No, it will first look for 5 factorial. Then when it's looking for 5 factorial, it needs to know the factorial of 5. But even before it finishes to know the factorial of 5, it has something. You can have something like a stack. Like it has something like a stack. It can go and place there the factorial in that stack. Then it moves ahead and goes to factorial 4. You see, even before factorial 4 finishes, it moves to factorial 3. 3 starts immediately. Before it finishes, 2 starts immediately. Before it finishes, 1 starts. And then when it reaches 1, then it terminates, because it will have gone through, like, recursively through the entire factorial. So you'll realize that after it reaches 1, there is no any recursive call that is needed. So it will return 1. So the factorial of 2 is now the next. You see, because it has already finished it already got 1 at the end. So it goes to the factorial of 2. After it finishes the factorial of 2, you realize that when you come here 2, you see, here it will be 2, the n will be 2, then 2 times the factorial of 1, because you'll already have gotten the factorial of 1 as 1. So this part will be 1, then here will be 2. So you realize there it will give you 2 times 1, that is 2. Then it goes back to factorial 3. So you see 3 is multiplied by factorial 2, and you already have factorial 2 is 2. You see? So it multiplies 3, which is the n, times the factorial of 2. Then it goes back to 4. You see, it's doing recursively. So basically the goal here was to get this formula. When you get this formula here, you realize that this is the formula that will help you understand what is happening, because after the function calls and calls and calls and calls, immediately it will reach the base case, it will stop. But if there is no part that it's reaching the base case or it doesn't satisfy this condition, then you go ahead and return n times factorial n minus 1 recursively. I don't know if you people have understood. Yeah. Anyone who has a question? Have you people eaten? Okay, you can just say yes or no, then I'll move ahead. I'll go ahead.
I think I've understood.
Okay, thank you so much.
Yes, it's clear.
Okay, thank you. So everybody's on the same page. Thank you so much. So that is all about recursion. And if you want to practice more, you can go and check at the Fibonacci, or you can even check if you're counting the number, like you're counting, you write and like you're counting down. So for example, let's try to count. Like maybe you want to count the numbers, let's say from 5 to 10, or you want to count the numbers either descending or ascending. You realize that if you just call
Sorry, Linda.
Yes.
Can you just show us with another example?
Yes, I want. Yes, I'm showing you. I was just saying, like I was explaining it. I was saying, like you'll realize that if you don't introduce a base case, it will just go on up to infinite. Yeah. So how can we call it? Count. So let's say we want to count from I backwards. Let's say 10.
You can't define count as a function. It's an inbuilt function.
Pardon?
You can't use count.
Okay, yeah, true. Let's use count number, right? Count. Yeah, it's an inbuilt function. Thank you. Count down. Let's just use down. Yeah, is that okay?
That's great.
The calling hasn't been edited also. The last count.
Which one?
The last count, number 10. I mean, the count 10. Count
Yeah,
down
so
10.
yeah. It's okay now. You see, like it goes on and on, then it will reach, you see, it's so big, it will reach a Stack Overflow whereby it cannot go on, like, you see it's saying there is a recursion error. So what you do is, you need to introduce a base. So you need to introduce a base. So we need to introduce a base so that, def, let me just copy paste so that I don't do mistakes. Or I just work on this one. Yeah, let me just work on it. So I think you need to introduce a base. So you can say,
I think it's better you just copy so that if anybody asks a question, you can refer back.
Okay. Yeah. So this means that you'll introduce a base case. This base case will act as your termination point. Maybe if it reaches a point whereby you wanted to count down, and maybe if it reaches maybe 0, or if it reaches maybe negative something, it can stop. So let's maybe initialize and say if it comes to 0, then let it return none, then else is that okay?
Which one should come first? Is it the countdown I-1 or print I in the else? I'm wondering.
I think let's see. We have a syntax error at if is equals to 0.
Like, what do you mean by if?
If I.
I think if something is equals to 0,
Yeah, exactly. Thank you. Yeah. So this is how it works. You see, like, it will go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means when it reaches I is equals to 0, it stops, right? Yeah.
Yes.
But there is something that I've noticed. If you put the print here before the else, let's just try here. You see, it counts from 10 because it's counting down. But if you put it after, it's now placing it in ascending order. So the person was asking if print can be after or before. I think because it's counting down, then it prints I, then it starts now counting down 10, then it counts down 1 minus 1, 9. After it prints 9, it goes 9 minus 1, 8. Then it prints 8, it goes 8 minus 1, 7 until it reaches 1. Then when it reaches 0, it prints nothing. Like there is nothing that it prints. Yeah.
Wonderful.
Linda,
Yes?
can you go back to the function? You see where it's written none?
Yes?
Can you just delete the first N and write D, done, and then print it? I want to see something.
Okay.
Let me see. Okay, it's alright, because there's another function in the modules that it was even printing the word done. So I wanted to confirm.
Oh, okay.
But it's fine, yeah. It's good.
Okay.
In that case, we write, instead of return done, we write print done. If I equals 0, print done. Else.
Yeah. Oh, great. Thank you.
Okay, so I think under recursion we are good, right? Because I think the next example, I think it was the factorial, then the last one was under the explore. I had the merge sort algorithm, and
so sorry to turn you back, Linda. What is this function doing? Because I got out for like 5 minutes, so I did not. What does this function do?
It's calling itself.
Though I've understood how it works.
It's calling itself.
Okay, thank you.
Yeah, it's recursion. So I don't know if you people, I don't know how I'll do it, but because the last example on Explore AI on this topic was merge sort. Merge sort is an example of it also follows a recursive, like it's a recursion algorithm. But I think for you to understand, I need to explain everything under sorting, because under sorting we have the quick sort, the insertion sort, then you have the merge sort. So we have to understand merge sort from the beginning before even we implement it, so that we know what is going on. So I don't know if I can leave it. We just talk of recursion. I go to Lambda functions. Then when I get back to sort, we will check how that is being implemented, because we need to start from how merge works first before it goes now to implement. Then we'll see how the function will be calling itself recursively. So I don't know if you people are okay with that, because merge sort falls under sorting of elements in a list. What do you think? So that I just go to Lambda, then maybe I'll go back to sorting.
You are in charge. Please do as we did it.
No, you also must talk so that, but we, because I'll have that opportunity of explaining to you how a merge sort works, what happens, then we'll implement and write a function until it works. Then from there we'll understand how the recursion works. But for now, I can just go ahead and discuss how Lambda works. Then after Lambda, if we have time, I'll go back to sorting, because tomorrow we'll talk about classes. So let me just go ahead. Let me save this.
So if I may just give my understanding of recursion.
Yes.
Recursion involves solving a problem in bits.
Yes.
However, you have to introduce the base case first. That is the point at which the recursion will stop. Then you now introduce how the recursion will be solving the problem little by little.
Yes.
So it's in two parts. You code first the base case, that is where it will stop. Then you now introduce what you want the problem, how you want the thing to solve the problem, little by little, recursively.
Yes.
Thank you.
So the base case just acts as a terminator, so that it helps your algorithm not to, maybe if it outputs something, that something will not go to infinite loop, which will be a Stack Overflow, you'll get an error. So the base case helps that immediately you are calling recursively. When it reaches to that base case, then it ends there, like everything stops. But if it doesn't get to the base, it will keep on going until it, like the goal is for the recursive call to get towards the base.
Thank you.
Welcome. So I think we can talk about Lambda. So under Lambda, most of the time when people write, let's say, algorithms in Python, or you are just trying to code, most of the time usually write your own Python functions, you define the keyword, you introduce function errors, somebody will use doc strings. But there is a quicker way where somebody or a programmer or you as a data scientist, you can write the function on an easy way, like a fly and faster way. And that faster way of writing that function, that is what we call Lambda functions. Like it just simplifies the process. So in short, when you're writing Lambda functions, now you introduce the keyword Lambda. So this helps a programmer to write maybe fewer lines of the code, which comes in handy, especially when, let's say, you are working on a big problem. You can introduce Lambda so that you have fewer lines of codes while you are coding. So for example, I can just give an example. Let's say, for example, you want to multiply, let's say, A and B. You want to multiply a value, A and B. So basically, if you use, let's say, Lambda, you can say multiply multiply number. So lambda comes in whereby it takes you introduce the two arguments, like the two numbers that you want to return. So for example, the function defines a lambda function called here maybe our function is called the multiply number. Then the lambda function now, this one that I've introduced, will take the argument that you want to pass through. So let's say, for example, we want to pass the arguments x, y, right? So after you've passed in the two arguments, you place a colon, then now you perform the function that you wanted to do with those two arguments. So let's say maybe you wanted to get x plus y. Let me just place a space here. So let's say maybe you wanted to get x plus y. So if you try to do it, just a minute. So if you wanted to do it, it will be multiply number. Then now you can put in the arguments that you want. Can somebody give us the argument that they want us to use?
5 and 7.
5 and 7. Thank you.
And check your spellings, Linda, on the second.
Okay, multiply. Is it okay now? Yeah.
Yep.
I'm telling you I have a problem with the syntax errors. I don't know.
Lambda x, y. Lambda.
Yeah. And I'd written it. Where did it go? Yeah, that is it. So you check the lambda functions, then you put in the two arguments that you want, then you say what you want to do with it. So for example, even if somebody wanted to divide, let's say, or you wanted to multiply. No, I've used multiply. What can I use? Let's say divide, or let's say power. Maybe you wanted to do power of maybe two numbers. So power number. So definitely you bring in the function lambda. Then you put in the arguments. So let's say maybe A, B. After that, now you say what you want. You want A raised to, like A power
B. Power B.
Yes. So then you now put in the arguments. You can replace them with the values that you want. So power number. Let's say we have 10 and 10. Yeah. You get that. So anything that you want to do. So basically, the lambda function, it always allows us to write functions in a quick way, but sometimes it's a dirty way because there are instances where you don't use them. Like don't now, like the advice here is that don't rely on them so much, but they can come in handy when you want to reduce the number of codes, the number of code lines that you want. Anyone who is not understanding? So basically, if somebody maybe asks you a lambda function, you can just say the lambda function or the keyword is always used to create an anonymous function that can be assigned to a variable. So you are just assigned it with the function lambda. So after you've written your variable and then you introduce the function lambda, then you should pass in your arguments that you want to do. even if you want to do division or you want to find the kilometers per hour or something of the sort, you just pass in the lambda and then you put in the arguments. Then you now call the arguments under the variable, and then you replace the arguments with what you want to calculate or what you want to do. Yeah, so that is lambda comes in and in that way. So lambda always works with the lambda function always works with, let's say, at some point map, and also if you want to filter. So we can apply the lambda function to every element if you introduce the map, so that every element will be an iterable sequence using a build map function provided by the Python. So simply the map function is an inbuilt function provided by Python, but you can use it while using the lambda function. So let's see how that works. The map function. Okay, so for example, let's say you have a list of numbers. So let's say you have a list of numbers, and let's say you have 2, 4, 6, 9. So those are the list of our numbers. So you want to maybe map the function to apply the lambda function so that it can maybe look at each element in the list. So what we'll do, after having the numbers, it should be equals to, how can we call it? Maybe we want to square these numbers. Let's say maybe we want to square the numbers. So we can introduce a variable square all numbers, or just square. Then now map comes in. Then now you call your function lambda. So after you call lambda, we've said you should place in the argument, right? So let's say the argument is a, and what do you want to do to this a? Maybe you want to square every number. Then from there, you place the numbers that it should go through. So let's try and run it. Then we can print the square. So if you run it, this thing will give you is it an iterative function here? This is an iterative function. So in short, it's always advised that when you are working with map, you introduce the list, because if you just run like that, it will give you the map function will give you an iterative. This is called, is it an iteration or something of the sort? So lambda function, you need to, if you introduce the map, you need to introduce the list so that it can provide us with the iterable object. So it needs to be converted to a list so that it gives us the type of that iteration that it has performed. So for example, here we needed to take the list of these like that. I think if I'm not wrong. Let's see. So you see, it gives us, if you don't place the list, it will just give you the iterative function which you had seen. But if you introduce the list, now it gives us what is in that iterative function. So definitely we are mapping on lambda, then a raised to 2. Then a raised to 2, it will go through the numbers because that is the variable that we had assigned. So it will go to 2, it will give us 2 raised to 2, 4, 4 raised to 2, 16, 6 raised to 2, 36, then 9 raised to 2, 81. So that is how map works. like the map inbuilt function of Python. That is how it works. Anyone who has a question?
So, Linda, thank you.
Yes.
Thank you. I think what you gave us before you put the list was the address. I mean, the location in memory.
Yeah.
Where it has stored the function.
Yes.
Okay. Thank you.
Which is an iterable mini object.
Okay.
Yeah. So you can refer to it like that, or you can say it's an iterable object. So for you to change it from that iterable object to so that you put the list so that it can showcase what is the output. Yeah.
So the map.
Yes.
The map is for the list zone. The map is it used for a list for the list alone? Because
the map function. So the usage of the map function here is that it helps, or it's used to apply a lambda function to each element of the list. So it applies a lambda function on each of the elements on the list. So that is the work of the map function here. So after it applies the lambda function on each element of the list, and each element of the list here is the 2, 4, 6, 9. So it applies the lambda on those numbers that have been highlighted up. Then after that, it returns the iterative object. And that iterative object, now you need to convert it to a list so that you can see what the lambda function was doing on that element of the list. Because it mapped the lambda on the numbers, which are the elements. Then after that, you have to introduce a list so that you see what the lambda function was doing. But the main function of the map is to apply the lambda function to each and every element of the list. Yeah.
Is map only used with lambda, or it can be used with any other function?
Yeah, I'm not sure. I'm not sure. But I think because it's an inbuilt function in Python, then I think it can be used in various ways. I think it cannot only work. It does not only work with lambda alone, because the main aim of the map is that it works as an iterator, which results after applying a function to every item of that iterable or list, or if it's a tuple. So that means that you can map it even if it's not, because lambda is just an anonymous function, which means you can map it to any other function that is appropriate. Yeah. So I don't think it only works with lambda.
Okay. Is there a function we have defined in this notebook up there? We can maybe check and try one.
Pardon?
Is there a function we defined up there? Check whether there's a function we have defined up in the initial, like that fact.
Mm-hmm.
We can replace that fact and with lambda to see what it does in the list that we have done below.
So we create another, we try it on something else.
Yeah.
So we addition,
copy cell 17. The whole of it, cell 17.
17, this one.
Cell 17, down.
Okay. Cell 17.
We're just trying.
Okay, this one.
Just copy it, paste it in the next cell.
Mm-hmm.
And that will replace lambda a to a power 2 with the fact.
But now this means you'll have to define a function.
No, that's why I've picked what we have already defined up there.
Oh, so okay, yeah, true. Was it
just delete a to power. Delete. No, just put fact. You want to see whether it can get factorials of the list.
Oh, okay, yeah, true. That way?
Comma, numbers. Try to run.
So should I get rid of these numbers here? These ones?
Just run fast. Just run with that. We see.
I think that fact will have to be in bracket. I mean, we'll have to put the bracket in calling the function, isn't it?
So this one works. List map fact.
So what have we done?
This is what it gives.
So we have gotten factorial of 2, 4, 6, and 9. Or what have we done?
What is the factorial of 9?
We can check.
Yeah, that is what. Yeah, factorial of 9 is 362,880. Factorial of 6 is 720. So that is what it does. So it does not mean, like the way the person had asked, it doesn't only work on it does not only work on lambda alone. Yeah.
Yeah.
Thank you so much for that example. So we should move to now filtering. Anyone who's a problem with mapping, with using map and lambda function? So let's go to filtering. So when it comes to filtering, the filter function, it's also an inbuilt function. So it returns an iterator as well, just like the map function. But this means that it applies a specific function to each item of the iterable, filtering out those that do not satisfy the condition defined in the function. So for example, maybe you have a function, or the lambda function, and maybe you give the lambda function to maybe an argument and want to see if it's greater than or equals to, if it's, let's say, it's not equals to, greater, less. So that is when filter comes in. So filter function always comes in to filter out those that do not satisfy the condition defined in the function. So the result also of a filter function, of the filter function, is that it gives out the object, the object or the iterative object. So that means that you still have to introduce the list so that it prints out what you wanted. So for example, let's try it maybe on a sequence. Then let's say our sequence has let's say 10, 3, 5, 8, 10, no, 9, 23. So let's say that is our sequence. So let's call a variable filter.
Linda.
Then this variable, yes?
Yeah, you've just like added a bracket at the end. Yeah.
I've added.
It's fine.
Okay, oh, I've fixed it. Okay, thank you. So filter, we can introduce now the filter function. Then it applies on the lambda, and the lambda, let's say we have an argument, let's say b, and we want to check if b is greater than, let's say it's greater than 3. Yeah. Then the sequence. So let's print the sequence. We print the filter. Yeah. So you see, if you don't introduce the list, it gives you the filter object, like the iterator. This is the object. So for you to get it, you have to introduce the list. So let's see how it does. Where did I go wrong?
Maybe filter, maybe use something else in the name.
Here.
The first filter, you can call it maybe filter 1 or something. Yeah.
Like that?
And then, yeah.
Not yet.
Could it be like the brackets? I'm trying to count like those brackets that we have used.
Yes, so this one is 1. So this one is closes this, then this one closes this. Or still we can do this. Let's see. Help to know where the problem is.
You even see, like Linda.
Yes.
I think it still not work because you see the word list and filter. They are all in green color. I think when they change that color, that's why you would be like.
There's no. They need to be in green. Just like this, list, map, lambda were in green.
And then was not working.
I don't know. Hey, people, help. Can we debug? I don't see any problem because this is the sequence. Here it's the sequence, then the filter lambda b, then the argument, then the
lists. That's lists on print lists.
Here.
Yeah.
So we need to print list also here.
No, you remove it there.
Here?
Yes. I'm just trying, I'm not sure, but we can try that.
So it comes here.
Yes. Then add the other brackets.
Not yet.
Okay.
Can you people see any problem here? I don't see any problem. Can you talk, please?
I'm trying to ask ChatGPT that object is not.
Yeah, do that, please. Because I don't see any problem here. And they're saying our error is on filter 1. Let me try to.
What is, oh, I don't know.
I don't see any problem, but it's because here, let me try and
Linda.
Yes?
Let me paste information that ChatGPT is saying.
Okay.
Then I believe that members here can like also try read it and understand. I'm pasting it in the chat because I'm not even like getting it. Let me paste.
Okay.
Lina, please, could you also paste your code in the
chat?
Yes, please.
Okay.
Wait a bit. I paste everything first and then you paste, Linda, so that it can flow. I'll let you know.
Or should I rename it? Let me try renaming it.
E16 storage. It's not a lot, but for an apartment, it could get stretched out and long.
What happened? Let me write it again. Hello. Let's write it again. Yes, there's somebody talking. Yes, just talk. Don't worry.
I'm done pasting the text from ChatGPT.
Okay, I was trying to rewrite it again. Let me paste the one that paste the other one if you are done. So the other one is so this was the one we had. So you people can pass it through ChatGPT. So let's see. So this one says the error filter object is not callable. Typically occurs when you are trying to call a filter object as if it were a function. The filter function is in Python returns an iterator that produces items for the iterable. For which function? Here is an example how we might encounter these. As 1, 2, 3. So that means that let's try not using the filter or filter something. Let's
Linda, try put a space. Linda, try put a space between B and greater than.
So let me go back here.
Put a space. Where is it? Where is it? Put a space. They feel like they are struggling for air.
Linda?
Yes?
Mine has worked. I've just taken your code and pasted it. Yeah.
Same here with me.
Then what is wrong with mine? Are they the same with this one?
Yes, what you have shared on the chat.
What you pasted is working on my own too.
Yes, and here it's the same. Or let me paste on the chat. Then let me copy paste it and see. Where is it? Here it is. Let's see. You see on my side it's not working. I don't know why.
Because these are machines. I don't know whether you should save and then you close and reopen. Like this file, you close it, you save first, close, then reopen again.
So I've cutted the. Let me save. I've cut the cell, then I've opened a new cell. Let's see. You see it's not working. So let me save. Then you said after saving, I close it.
You have to restart. Okay.
I restart.
You save and then.
No, Amma, you close it.
Can I restart and run all? No, that will run every cell. Okay, how many have tried and it has worked for them? But I think the message is.
Nila,
yes.
I've just that code that you did paste on the chat.
Yes.
I don't know what other members have used, but me, I've used Google Colab and it has worked.
Okay, so the problem is on my end.
I don't know what others are using. They're using.
Yeah, I'm using Notebook and it has worked.
Notebook.
Okay, so meaning it works. Have you tried to put the list?
Yeah, I've just copied the way it is.
That's the way.
What I'll do, let me just stop sharing my screen for a minute. Then you can one of you can share so that others can see it. Then you go on because I can't keep on I don't want stress. Okay, can one who was it?
Let me share mine.
Okay.
Okay.
I think maybe there's a problem with my because I don't see any problem in that code.
You guys can see my screen?
Yes, we can.
Okay, let me go to where I pasted that Google Colab. You can see that's the function.
Yes.
And it has worked. Is that the answer that you're saying?
Yeah, because it's going through it's checking if the value it's picking values greater than 3.
Yeah.
So you see it eliminates 3 and picks 10, 5, 8, 9, 25. That's how it's supposed to work.
Mm-hmm.
Yeah, so the answer is correct.
Yeah, exactly. In fact, even ChatGPT was saying that if you try and look at our text there, after pasting it on ChatGPT, and this is what ChatGPT said, that your code seems correct and it should work as intended. So I believe, I don't know why yours is not working.
Then it says
ChatGPT says that it is correct, and the filter function is used to create an iterator, so it was correct.
Yeah, so I don't know, but you remember, okay, PG?
Linda.
Yes?
I had a problem with mine too. It wasn't returning anything. I just restarted, like the restart button at the top of the notebook. I just restarted it.
You restart the kernel. I restart the kernel. Thank you.
Yes, you don't even have to run on, just restart. And then run this thing once.
Okay.
Yeah, it works. Yeah, it works. Thank you so much, PG. Thank you so much. Yeah, it works. I think the problem was on the end.
What are we trying to solve? Sorry, I wasn't
We were
around.
trying, I had run my code and it was not working and it was correct. So I had to restart my kernel. Okay. So it has worked actually. It's here. It has worked.
So what were you trying to solve there, Hora?
No, the code was okay, but it was not going through. It was saying that I had a problem on line number 2.
You were trying to illustrate the lambda, function.
Yes.
Okay.
So anybody, I think we are done with the lambdas. I don't think if you have anything else to talk about lambdas, unless somebody has a question. But definitely that is it. So you can go ahead and maybe read more on the internet or you can even watch a YouTube video just to see how it works and many more examples about it. But it only comes in handy to make work easier, but it's not good, it's not recommended. But it comes in handy maybe if you want to solve a big problem. Yeah. Because if you check this one, you can also go ahead and define a function. Then you say for I in this, print this, else do this, you see. But for lambda function, it makes it easier for you to just go ahead and pick the value that is greater than 3, or pick the value that is lesser than 10, or multiply 2 numbers. But if you write an algorithm where you're defining a function, you can have, let's say, 5 code lines. But here you see you just have even 2 code lines because the last code line you're just printing the list. So that is how lambda comes in. Yeah. So it's not that difficult. So that is all, unless somebody has a question. Everyone is okay? You can send me thumbs up if you're okay. Okay, thank you so much. So what do I do? You people, should I go and do the sorting because I was prepared to teach the classes and objects tomorrow?
Yes, you can do sorting.
Okay. So if I start sorting, don't confuse it with searching. they seem to work the same. Okay. Okay, so for sorting, basically, sorting means that you are putting the elements in a list in a certain logical order. And it always comes in maybe if the list is not sorted, so you want to sort it. You see? So for example, in Python, we already have the inbuilt functions like sort that can help you to sort a list if it's not arranged well, or if it's not in ascending order, or if it's not arranged in the way you want. But sometimes it's good for you to know how this works. So that's why they introduced us to the concept of sorting, so that you can see how it's useful for greater flexibility and sometimes to improve the efficiency. So in short, just know that a sorting algorithm puts element of a list in a certain logical order. And this means that it applies 3 cases. That means that it searches the algorithm as much as quicker on the sorted list. Then it selects items based on specific characteristics such as the smallest value or the largest value. Then it finds duplicate in a list in an easier or much easier way if the items are sorted. So we'll just go ahead and start with the bubble sort. I know this one will even take an hour. So for bubble sort, basically, it's like it bubbles up. You see, like, how do you say? Like, it bubbles up the largest element within the list to the end of the list, then the second largest to the second last position to the list. Then each bubble list takes up a full sweep through the list. So it moves the largest to the end, then the second largest to the end, until the smallest elements comes to be the first one. So let's do it practically. So I think this one I'll use an R markdown. And feel free to ask any question, or feel free if I confuse anywhere, because I know you people are very knowledgeable so much. So I believe if you just see I'm confused, just tell me that is not how it is, or do this, and this, and I'll appreciate. So in bubble sort, basically the goal is to make sure that the largest element goes to the end of the list. Like we need at the end of the day, this 75 should be at the end. Then which one is the smallest? 6 should be the starting point. So basically, it always looks at the value at the first position, right? So the value at the first position, you can call it the J. The J. Let's say this one is the J. The J. Right? So it goes ahead. So that is the J. So it goes ahead and looks J. So what if you move one step ahead? What will our 42 be? Anyone? What will be our 42? Pardon? It will be J plus 1, because you are moving one step. You see? So the goal here for the bubble sort is to compare J and J plus 1. That is the goal. So the first thing in this our list, you'll compare J and J plus 1 and ask yourself, is J greater than J plus 1? If J is greater than J plus 1, then you swap the two numbers. But if it's not, you see, you move to the next, because you'll not swap. Anyone who has a question up to there? Is everyone okay?
Kindly repeat again. I'm trying to load it, but I'm not getting it.
Yes, thank you so much. So for bubble sort, you have the list. The list is unsorted. You want to sort this list. So this list here, the first one on your list, will be your jth element. So you'll give it a J. Then the next list, because you've moved one step ahead, that will be J plus 1. So here I'm not using anything like indexing, like what we've been doing in searching. I'm not saying index 0, 1, 2, 3. No, we are not doing that. So your goal is to compare J and J plus 1, like the first and the second element. I can simplify it like that. So you compare the first and the second element. Then when you realize that the first element is greater than the second element, you swap. That means that the second element will go back to the position of the first element, and the first element will go to the position of the second element. But if you get that it's not greater than, don't swap. You move. You move ahead now. Okay, so that means your J will move now to the next one. Have you gotten it? I can repeat it even the third time. Are you okay? The person who had asked me, because I can't see the screen. Hey.
Ambale?
Who had asked me that he had not understood?
Ibrahim.
Where is Ibrahim? Ibrahim, what is happening?
I'm here.
Have you gotten it, or I should do it again?
No, I've gotten it because you have said that our first element is the Jth.
Yes.
So the next element should be like something greater than J. So if you find out that J plus 1 is less than J,
yes,
then J plus 1 should come to the position of J. Then J goes ahead.
Yeah. So let me just write here so that if somebody wants to share the. So we've said if J is greater than J is we swap. If not, move ahead. Okay, so let's start. Is 23 greater than 42? Is it?
Nope.
Nope. So what do we do?
Swap.
We move.
You don't swap.
You don't swap, yeah. So no, so do not swap. The reason why I'm explaining for it this way, if you understand this way, it's easier for you to write the code, the algorithm, because you'll be understanding why they are doing it that way. But unless you'll be just saying J plus 1 minus 1, then you wonder what is not happening. But if you do it like this, you'll understand. So 23 is greater than 42. It's not greater than 42. So not greater than. So we do not swap. So we move. Okay, so up to there's nobody who's going to be, like, I don't think anyone is stuck. So when you get there, we now come. You realize that, let me just write so that people now understand. 42, then 75, then 8, then 6, then 9. So that means our J value is now J. Then our J plus 1 value is now 75. So again, you go ahead. You check. Is 42 greater than 75? Is it?
No.
No. So you move. I don't know if you people are getting it. If you get stuck, please just ask me. I'll explain again. So you go ahead again. You are not swapping it. Then 75, 8, then 6, then 9. You go ahead. So that means our J will be at 75. Then our J plus 1 will be at 8. Then you do the same. You ask yourself, is 75 greater than 8?
Yes.
Yes.
Yes. Yeah, I want you people to respond. Yes. So what do we do?
We swap.
Exactly. So how will it look like? It will be 23 then 42. Then
75.
Then
75.
Yes, thank you. Then 75. Then 6. Then 9. Who is lost? Who is lost? Anyone who is lost? Nobody. So you come again because we were at J75, which was here, and 8 has gone back where 75 was, and 75 has gone in front. Our J remains at that 75. Then J plus 1 is at 6. Why is it writing the yellow color? What happened? What did I just do? But there's no problem. So again, you compare now 75 and 6. So is 75 greater than 6? Yes. So you swap. Right? You swap. So you have 23, 42, 8, then 6, right? Then 75, then 9. Who is not getting it? Then you repeat the same thing, like it's bubble sort. We want the biggest element to go to the end, and we want the smallest element to go to the end on the left, and the biggest element to go on the end on the right. Like we want to sort this in ascending order. So our J plus 1 will be, I'm not now going to write the J and J plus 1 because you people have now understood what I'm doing. So our J will be 75 and our J plus 1 will be 9. So is 75 greater than 9? Yes. So you swap. So 9, then 75.
Yeah.
So you realize that 75 has now gone to the end. You see? So when you reach there, can I highlight? How will I highlight it? Is there anywhere can I highlight it to give it a color? Okay, no problem. Let me just leave it like that. Let me just squeeze it at the end. So you realize that if you look at this list, you realize that 75 has now gone to its position. True or false? Because it's the largest. Right?
Yeah.
So you go again. So this is the, I can say like this is the first pass. This is the first pass. Now the second pass, we are only remaining with, so that 75, you just leave it there because it's at the correct position. You now come to 23, 42, then 8, then 6, then 9. Then you repeat the same thing. Is 23 greater than 42? No. So that remains.
No.
Is 42 greater than 8?
Yeah.
Yes.
Yes, so you swap.
Oh,
So
you
it's
swap.
8 and
42.
So that will be 8, 42, then 6, then 9.
Yeah.
Yeah, I don't want to jump so that somebody asks what happened. Then we go ahead. We are now at 42 because they switched with 8. So is 42 greater than 6? Yes. So you
Yes.
swap. So it will be 23, then 8, then 6, then 42, then 9. Then you go and ask yourself again, is 42 greater than 9? Yes. So 23, 8, 6, then 9, then 42. You realize that 42 is now at the correct position. So you ignore it, you ignore it. Now your list is, you've remained to sort the remaining. So let's define. I hope this time around I won't have issues with indentations, but don't feel bad about that. It's because most of the time I've used Python not in statistics. I use it in combining when I work with maybe JavaScript or like the software engineering part, not the data analysis part. So list and then length. So let's pick the length of the list. Length. Let me not use my list. You told me not to use that. I don't know what is wrong with me. So the length, my list. So we define a function called bubble sort. Then we place the argument my list inside. Then we check at the length of our list. Then we iterate. We need to iterate in like this list. So that means for I in range, then the list, this will be my list.
My list.
Yes, my list.
Semicolon, colon.
Will it be semicolon? Then?
No, colon.
Colon?
Si hapo, yani,
okay, at the end.
At the end.
So we are looking, it's going through the length of our list. So is it okay if we do this? If we just say list length? Actually, let me just say my
Actually, you can just
length.
do my list length.
Yes,
So you
because my
the
list,
length of the list.
yes, actually that is okay. So my list, then length. Okay. So then the column that now you are talking about, right?
Mm-hmm.
Yeah. So let's now do this. So the I is iterating, and this will be our outer loop. Our outer loop will iterate as many times as the length of the list. Like it will be going through that 23, through that 8, through that 6, through that 9, through that 42, and through that 75. You see? Then we'll have now an inner loop, which we'll call it J. Now you understand why I was using J. You can use B, you can use something, but I think J was the best in this. So for J in range, because now this is now the inner loop, right? So for J in length, then we'll return, it will be my list, because it's also going through that list that the outer loop is going through. You see? Because this J, on each iteration, the inner loop will iterate as many times as the length of the list. And also the J will now be going through that range and comparing the numbers that are in that list. Okay? So it will be my list, then length.
My list length.
Yes. Then I think here we should subtract -1 because of that indexing here, and also here.
-1.
Yes.
J to -1.
Also this one. Because here J it a minus, because it's the length of the list, and the length of the list, like for example, come on 10, the length of the list will be 9, right? Yeah. So you -1, but in J,
That be my list line.
Pardon?
Should that be my list line, not my list line?
I didn't get you.
That last one.
This one?
Yes, it should be my list lines.
It's on our
range. That's my list.
My list length. Yeah, okay, I get you. I think I was not getting it. Thank you for that. Yeah. So the reason why we are subtracting the I is to avoid checking the already sorted values at the end of the list. You see, because if okay, you can leave it, there is no problem, but this is just making it easier, because why will my program go ahead and check at 75 and it has already sorted it at the end? Why will it go back and compare with 42, and 42 is already at the right position? So that is the reason why the -1 is coming in. Okay? Are you people okay?
Yes, you're very much okay.
Okay.
No, me, I'm no. Slowly, go slowly. I have understood J. Repeat, please.
So where? From the
for
start?
J.
For J.
For I've always understood about for I you have to -1.
Yes.
But when it comes to this list, I can't understand why we are minusing I and minusing 1.
Okay, we are -1 because the length of the list is always n, but the range will just be from the index value 0 to index value 1, right?
Yeah.
So let's say if the list of your element had 10, what will be the length of your list?
9. I'm at 10.
Exactly. So that is why
9.
we're subtracting 1. Then this I that I've brought in here, this one now helps us to avoid checking the values that you have already sorted. So let's say, for example, the first iteration goes and even places 75 at the end. Why will it go back and check if 75 is at the right place?
Oh, so we are trying to tell it, usirudie, don't repeat.
Exactly.
That's already done.
Yes, just work on the remaining ones that you have not sorted and continue sorting them. After you've sorted it and it's the right place, leave it alone. Then go back again. After you've sorted it again, leave it alone. That is why. But I think it can work without that. But I think that is the best way to make it so that the time complexity is reduced. Yeah.
Okay, thank you.
Then you people, you'll just tell me if I confuse on indentation, just make sure you help me so that our code can run. Because I usually feel very bad because of indentations. Okay, so from there, so I want you people to reason this way. From there, you've seen the ith value has iterated, like the outer loop, which is the ith, has iterated as many times in the length. Then the jth one, also it's a loop, it has also iterated as many times as the length of the list, okay, minusing those ones that have been sorted. Like it looks at the jth value is now the one that is iterating to sort it. Actually, that is how I can explain it well. Like the jth comes in to sort it, to check is it sorted or not, is it greater than or not. You see, so we'll have to bring in our condition if my list j is greater than my list j plus 1. What do? You swap. See, that is what we said. Did you say we swap or we don't swap when it's greater than?
We swap.
We swap, exactly. So can we write it? So we say if, will it be there or will this if be here or will be here? Can somebody help me?
It should be there.
Here where I am, it should be in that way, right?
Yes.
Thank you. So if my list, then the value at j is greater than my list.
In the right place though.
Pardon?
The first follow.
The first?
Shouldn't follow.
The first column.
4. The first 4 from my list length.
So what about it? I can't hear her.
She's asking if it's indented correctly. Because
this one?
Yes.
I think it is. So I can, maybe I can give it space.
The first one.
This one 4. Yeah, I think it's correct. Because here we were just making sure that we define the length of my list as my list length.
I think it should be the same as my list length after definition.
Yeah.
No, just take there.
No. There?
Yeah.
So this means I should also check on this one. Yeah, I want us to do that because I don't want us to have those issues of indentation. They usually stress me out and they waste your time and there's nothing you've done wrong.
Before you figure out it's the indentation.
Yeah, it's so bad. A very bad feeling. So I need to. Okay, I can just do this. Yeah, that looks good. Yeah. Yes?
My list j is greater than my list and the list before that.
It should be?
We removed if.
Yeah, true. So I think I should give it space. Like that, right? Yes, it's true because we want to see if it's greater than or not greater than. So this one is it's j plus 1. So what did we say? We said if my list J is greater than my list J plus 1, you swap. So that means if the list was, it must be my list. So that means that if my list was arranged in this way, it was J, then it was followed by my list J plus 1. That means it swaps. So which one starts? My list. My
J
list.
plus 1.
Yes.
J plus 1.
Then comma.
Comma. My list J.
J. Like that. Who is not with us? Like want some explanation? Maybe they are lost. Anyone?
Can you just come again one more time, please?
We go through it again. The whole algorithm. I go through the whole algorithm. Where?
No, the code part. You know,
This
that. Yes, that's yes. Then you also mentioned the reason again. I heard you when you said the reason why you said -1, and why once that code is sorted, you should not go back to it. You can just go back while you're explaining this code block. You could just also mention it again, so we take note.
Okay, so basically, you've defined the function already. If you already understood what we were doing here, you realize that is what this code is trying to do. This one. So you already defined your function. Then you've placed the argument my list. So here we just looked at the length of the list because we want to iterate through that range of that list, and the range of the list should be the range should go through the length of the list. Like when I iterate through that list, it should go to the entire list up to the last element. So the first iteration, this I in range my list -1, it's like this is the list. So this iteration, it will iterate as many times through these lists. You see? As many times until it reaches the last one. But here now the for loop scans in, it iterates, but keeping in mind that it is looking for if the first list and the second list, like it's checking if they are greater than or less than, if they are greater than or less than, if they are greater than or less than. You see? So that is the inner loop. So after it iterates through it, we are subtracting -1 because remember in Python, your indexing starts from 0. So if our list had 10, the range of the list will be from 0 to 9. That's why we are saying my length -1. Then for J8, we are subtracting 1 because we don't want our program to sort those elements that they have already sorted. But I've told you another person can do it without the -I, which I think will just still work. But I placed in the -I so that it checks. Like when it's iterating, you see, if the J is iterating, then it gets to the last, let's say for example here. You see it comes here, the J, it iterates as it compares. The first one, it compares with the J plus 1, it compares. Then let's say it reaches here. Then it compares the 9th and 75. When it reaches here and it realizes this is already sorted, it does not do anything. It just goes back and work on the next list that has remained unsorted. So that is why the -I is coming in. Then after that, we now come to declare our...
Please,
yes?
Just a minute. That's -1. When you are talking about the indexing, if you put -1, how does that make it 10? How does that how does that change the length of the list to 10?
Okay, let's use this one. 1, 2, 3, 4, 5, 6. Right?
Yes.
You can answer me. So what is the length of this list? So what is the length of this list? Is it
6?
1, 2, 3, 4, 5, 6?
6.
Is it 6 or is it 5?
It's 6 in normal length, but if we use the indexing, it will give us 5.
Yes. So that is why we are subtracting 1. Because it starts from the index value, which is 0. Then it iterates through the range up to index value number 5. But in real sense, if you go it directly, you realize that it's going from 1 to 6. You see? So we are subtracting from 1 because of that, that condition.
And as I'm saying now, that if you minus or subtract 1,
yes,
how does that change? For instance, if the length is 6,
yes,
right? If you subtract 1,
yes,
is that not going to make it 5? Because I'm not able yet to picture how it turns that to 7. You know, I'm seeing it dropping the length of the list even further. That's what I'm trying to find out.
Linda.
Yes.
If I may comment.
Comment? You want to? Yes.
If I may, just to help.
Yes.
So, Roy, if you look at that J is just telling you, it's just preparing for the positioning of the item, for the position for the index, for the indexing. That's the function of that J there. So, if I may, I like to read this thing in plain English. Let's start from that first iteration for elements in the range of my list. Yeah. Okay, so let me start from my list length is the length of my list. For each element in the range of my list length, that is the length of my list that we want to. Now, for each position in this range, that's second.
No, Anthony, you skipped that -1. Is that -1 I'm interested in, please?
Okay. So for elements in the range of my list -1. Now, so my list it has 10 elements. My list has 10 elements. For each of the elements in it, that is for I in all this. So I'm going to go through all my lists. Apart from, and each of my lists will end at -1. You know, I think you already understood that one. That the indexing starts from 0 to 9. So if the length of my list is 10. From that -1 from that one of my list, so my list is now 0 to is now 9. The length of my list is now 9. Do you understand that? Yeah, I think that one was clear. That the indexing of my list is starting from 0 to 9, which is if my list is 10 elements. So for these 10 elements, the indexing is 0 to 9. So minus that one. That's for the first -1. Now for each of the position of the length of my list, for each of the position, when you get to the last one, do not repeat the index again. That is the one you are holding at the moment. Do not drop it when you get to -I.
Okay, so you are saying that the nested for loop, you are saying that it checks the list, then when it gets to the last one, what does it do with I? It takes the element in I to do that -I, okay, to compare it. Or what does it do? That -I.
So that -I is simply saying that, okay, drop. You know, you are going through each of them. Each of them is I. When you pick the first one, you have picked I till you get to the index of 9. So when you get to So and J now is that each position in this my list, each position is with the index of 0, index of with the number that occupy the index of 2. That is this J. When you get to that -1, drop and you have performed the following if condition, drop that I. Drop that last number and go and perform the following. Go back again.
Or is Ray? You're the one who was asking the question, or you wanted us wanted the first loop to just go through the length. Then maybe the jth now to go from the index to the last one. So do you wanted us just to iterate through the entire list for the outer loop? If that is your argument.
No, I'm saying the first one.
This one.
I'm getting yes.
That's why I'm asking you from your argument. You mean we need to do it this way? This way. Is that what you want it to be?
Yes, that's what I'm thinking it should be.
Okay.
No, I'm not
Anyone else? What are you people thinking? Hey, talk. Let's talk so that we can move from bubble sort to go to the next one. Do you people think we should iterate through the entire list, just the length of the list? Or we should iterate the list -1 so that it comes from 0 to 1? Is it the same thing?
No.
I think we have to use the
index. It's not the same thing. If we use that range.
Okay, let's try both. Let's start with this one. Let's start with this one. Then we'll see if we get an error. Then we'll know. Because as I told you, this is something you're writing from scratch. So let's see. So the return will be here.
Yes.
Help me with the introduction, please. I don't want it to look weird. So if my list J is greater than my list J plus 1, you swap. Else return what? What can we return? What can we return?
My list.
Yeah, we can return the list. Thank you. Okay, I hope we don't have an error. Let's see. Yeah. So let's try it on, let's say we call just a function, then we see if it will work. So bubble can somebody give me any numbers, or can we use the one we used here? This one. I hope it works, but that is the logic of that, everything that we've done. Or we can do this, we can say my list, let's do it so that you understand. That will be like I've skipped many places. So our list is this one, my list. Then here we place my list, right? Does it make sense? Like that?
Yes, but yes.
Yeah, it's making sense.
Yeah.
That's you.
But we need to remove the brackets on my list.
Where? This one.
You need to, yes, this outer bracket for both. Okay.
So it doesn't. And what if we remove the one? But there's a problem with my kernel again. Okay, it hasn't sorted. So we need to figure out, is the return my list at the right place?
Linda,
Yes?
why don't you return that one, because you just restarted your kernel?
Yes.
Return the one, and no, we're going back.
Here.
Yeah, return it. No. For I in range, you had -1. Huh?
Oh, like that.
Yeah, because you've started your kernel again. Let us start afresh so that we can see where are the errors.
Okay, thank you.
Yeah. So so that when you now remove I, we'll know, as in we'll be able to understand, removing 1 bit by 1 bit by 1 bit. So it's still not working.
Yes.
So we need to check.
I think the problem is
remove the one from inside the bracket. It should be outside. I would try putting it outside.
I think the problem is
that like for I in range, my list, then put -1.
Also
the other, you put it outside the bracket.
So this will have double? No.
No. As in, you see my, that one is correct. That one is very, very correct. I would try that one. If it refuses.
But this one, this value is red. This closing.
Well,
because it doesn't have like an opening one.
You don't have an opening one. Add another bracket, an opening bracket. Yeah.
Yep.
Thank you, Ibrahim. Yeah, it has worked.
It does. It has not.
No.
Okay. Linda.
I'm sleepy.
Okay. Yes. Yeah, that was Nemo's suggestion. That's suggestion number 1. It does not work. Let us go to, I think, Ray. Ray wanted to say something. Ray, can you say your solution so that we implement it and see if it works?
Okay, so I was... Okay, go on, Anthony. Anthony, please go.
All right, thank you. I was saying that, I wanted to say that we have not initialized the result that we wanted. Or let me put it this way. We are still returning our original list. We are asking to return our original list. I think we need to return the sorted list. So I think under we need to open we need to define a variable called sorted list. Then we now say return sorted list.
Where? Here. So this return list is for the outer loop, right? Then for the inner loop, if my list is greater or equals to this, my list, you swap. That is the condition, or else you return my list. So where do you want me to change?
I think I think
so what Anthony was
here my list. Oh, sorry. Ray.
Okay, so Anthony was basically saying that you know that Python runs from top to bottom, right? So Anthony, yes. So Anthony is saying that as you are using, my list as the one that runs through the whole process, you should have like inside the code, you should have like another name, like sorted list. Right?
Where specifically?
That at the bottom, just before return. Before return.
Before this one, there, here.
Yes. Yeah.
But it doesn't return something, it swaps. It doesn't return anything. The goal here is if my list is greater or equals to this, then you swap, or else you return my list. Then the loop continues. So you cannot return something there.
Can we call the function that we have just defined?
How was it? It was bubble sort. Bubble sort. Then?
My list, or what was it? My list.
Yeah, and that list, I'm just keeping in what we want, right?
Okay.
Please close the space. There is a space after the underscore.
Thank you. Not yet. So I think our problem is here.
Linda, what is J doing?
What
For
if we just
J
take
in range?
For J in range sits here? And what if we do this?
What is it doing? What is it doing? Please explain that one.
For J in range, basically, you see after the first loop has iterated throughout all the elements or all the list that you have. So the Jth elements, it comes also, it iterates, but with the goal of checking the first value and the second value to check if it's greater than or less than, so that you can be able to swap or not. That is the goal now of the inner loop.
You haven't specified which is the first value and which is the second value.
Where?
The J in range, you've written only one element in the brackets.
Okay, let me just, am I in the right place? Okay, so which element have I only in the bracket here? For J in range, then the length of my list.
Yes, maybe you're comparing what the first one, maybe it's a 0, and then the second one is my list length minus 1 minus I. So
yes.
you're comparing, you need a comma. You need like maybe 0 comma, my list.
Wait, so 0 here. Here. Like that.
I think I've got where the problem is.
Right.
Okay. Where's the problem? Because I wanted to change these so that you just
try I see. Try I see what is doing.
Then let's try and change this. Okay, I'm just trying. Then the person was saying he knows what the problem is. If it's not this way, then we'll see what to do. Is it written okay?
You see that J, it has to be 2 elements. You're only putting 1 element. For that J in range, you have to have 2 elements in there.
Okay, so you said I put 0 here.
Yeah, maybe just a 0 and the next one is minus 1 minus I. It makes sense.
Like that?
Not there. 0 should be the first one and then the next one is that thingy.
So 0 should be here?
Yes, 0 comma, then my list minus 1 minus I minus 1, yes.
So this, you want it to be like this? Is it okay?
Yeah.
Like, have I done what you want me to do?
Yes.
Okay. Not yet. It's still giving out the way it is. Or can somebody try this code on their
So can we go back to the
paste on the chat?
Okay. Let me paste the.
Let me try getting rid of this. Let me see. And I'm wondering why is it not running? Okay, let me paste it on the chat. Oh, let me undo first.
So Linda,
let me undo the way it was first, then I paste it. So here.
Linda.
Yes.
I pasted the original code
on the
chart.
Okay.
And I've corrected it. So if you copy it and paste what I pasted, now if you copy it and paste it, it will work. And I'll tell you where our problem was.
Okay, let me copy it down. Yeah, that worked. So where was our problem? Because I'm seeing it's the same. Everything is the same.
It was in the equals to.
Equals to.
Yes, you put double equals to.
Okay, here.
Rather than a single one. Yes, that's where our problem is.
Yeah, thank you so much. And imagine I was just looking. I'm wondering what is not happening.
Wait.
Okay, we are now
the problem? What was the problem? The double.
We had 2 is equals to signs here.
Only.
Yes, imagine. And only one person was able to see that.
Then we
Thank
stayed
you
for
so
15
much.
minutes because of unequals.
Imagine. Who was that? Anthony, thank you so much.
I'm still. Somebody please explain the J. Only the J. It will make sense for me. Please.
Anthony, can you explain for her what the J is doing?
Come again, I didn't hear you.
I'm saying, can you explain to her what the J loop is doing?
Okay. Let's go to the code. So the J is telling the code that for each of the positions in this our list, do the following. That is for each of the index in this our list. Do the following. That is, if the index of J, if the first one is greater than the index of the next one, that is J plus 1, do the following. That is swap. If not, return our list. So the first for loop is asking us, go through the length of my list. For every element in the length of my list. Now, that is for I. That is I is representing element for all the elements in the length of my list. Then for each positions in this for each index in the length of my list, if the position of J, if the index of J is greater than the index of J plus 1, that is the next J, the next goes to J, swap. If not, return my list. I don't know if that's
so just by saying that, what is the index of len my list minus 1 minus I? What is that index? Because I understand that len my list minus 1 is the last index, right?
Yes.
So what is len my list minus 1 minus I? What is that index?
So the reason why we are subtracting the I from after you've gotten my list minus 1 is for your program to make sure that after it has sorted an element and it has realized that this element is at the right position. For example, let's say you have 2, 3, 100, 10. Then it goes through the first iteration and it happens that 100 went to be the last position. You see? So you are instructing your algorithm, like when it runs, it ignores that 100 because it believes the 100 is the largest number and it's already at the end. So it doesn't have to go and compare it again to the others. It will just leave that 100 and now go back to the remaining 3 to also sort so that the second largest goes to the second, like the second largest goes to the second last part. You see? So that is why we've introduced the minus I. But this my list, the length my list minus 1, that comes in because if the list was from 0, it has 10 elements, it means the length will be 9, okay? Because it will move from 0 to 9. But the minus 1, we are just making sure that once you've sorted that element and it's at the right position like it's supposed to be, then don't go through it again. Just the J loop will just go to iterate through the remaining ones. I hope you've gotten it.
Yes.
Thank you so much. Yes,
Linda.
John has. You can talk, John.
Excuse, I have a question.
Yes.
We'll go back to the code. Why are you using for I in range length of my list? Why couldn't you just pass my list length in the?
I think it will do the same. It will work because right now because let's do it, right? Let's do it. So you want it to be my list length, right?
Yes.
Then here will be Was it like that at the first time? Does it look okay before I run it? My list length, there's no spelling errors. So let's see. Yeah, it works the same. Because it will work because already you said you are my list length, you've already told it it's the length of my list. So whichever these values the same as this one, no matter what.
Please, can you just on a new code, on a new cell block, can you just run my list -1? Or my list length -1, sorry.
Like that?
Yes.
It's not defined. I think there's a way you should do it so that you can know how it is, because my list is this one.
Or do we just write the code directly? Either say my learn my list -1 or something like that. Yeah.
If you want to call the length of the list, that means you'll have first to give what is your my list. Then you go ahead now to look the length of the list.
Okay, let's give that 6. That's 6.
Can I write down?
Let's call it yes.
So what is the variable of it?
Let's just call it test list.
Test list.
Equal to that's 689 whatever.
Then
now we say learn test list -1.
Pardon?
Learn test list -1.
Length.
Yes.
Test.
No, learn, like you want to find the length of test list. Yeah.
Learn. I know the learn list. I think now it's in brackets.
Learn brackets.
And then test list.
List. Then -1. Assign it to a variable.
Which variable? How do you assign the length of the list to a variable?
Just call it learn test. Learn test as a variable. Yeah.
Oh, and then you print it. Okay.
Okay. Now let's print out learn test.
That way?
LEN, yes, LEN. Okay.
Are you satisfied? How do we say?
1, 2, 3, 4, 5.
Yeah, but there are 6. 0, 1, 1, 2, 3, 4, 5, 6. But -1, it means this one is 0, 1, 2, 3, 4, 5.
Zero, 1, 2, 3, 4, 5.
Yeah.
Okay.
Okay, are we good with bubble sort, or anyone who is lagging behind? Because we are now done with bubble sort. Anyone?
Please, Linda, can you do that thing without putting -1? Let's see the number that will appear.
Okay. Which one?
Just remove the -1 after the test list.
Like
and run
that?
it again. Yes. Run it.
6.
So if it is 6,
yes,
does that not mean that the lien of these numbers is 6? And then -1 is just normal mathematics, the lien minus the 1 that you put -1.
So -1, it's the Python way. Then this one is the mathematical way.
So why are we saying the lien there is starting from 0, 1, 2, 3, 4, 5?
Because that is how we count in Python. You don't start from 1, you start from 0, index 0 to when you move forward. You don't start from 1. You can't say that the index value of 6 is 1. The index value of 6 is 0.
Okay.
That is what is happening.
All right. Thank you.
Okay, you're welcome. Any other person?
Please let me.
Yes, Fikona.
I was knocked off by the network. Could you just explain?
I can't hear you.
I didn't know why. In the code again.
Okay.
Before I was knocked up from the network, there was an error in the code. When I came back, it has been explained, it has been cleared.
Okay, sorry for that. So where were you when you left last time?
Linda, please, we are going to share this Jupyter notebook.
Yeah,
so
100%.
Anything that like this -1 that is giving us, that is making us ask multiple questions. Can you just put a comment there so that when we are running it on our own, we see the comment and it brings back the reason, to mind. And that -I too, the reason, in a comment, so that it helps, as one looks at it on his own.
Okay.
Thank you.
We left Fikona. Fikona, just a minute. I'm a very bad teacher. You are talking and I listen to another student. Just a minute, okay?
Okay, thank you.
Okay, so Fikona, where were you? Here. Okay. So where did we leave you?
Okay, there was an error in the code.
Okay, so our error was because we had done this. We had 2 equal signs. So we got rid of that and it worked.
Okay.
Yeah.
Okay.
Are you okay now?
Thank you.
Welcome. Any other person? Should we move ahead?
Yes, let's go.
Okay, thank you. So the next one is the insertion. I think that was the next one, if I'm not wrong. Insertion. Sorting. Okay. So let me place this so that it's marked down so that it works well. So in insertion sort, you should understand that it also helps in to sort those elements that are not sorted, just like the bubble sort. But with the insertion, the goal of the insertion sort, like how it works, it inserts the element at the right place in the same list. Like, for example, if you have a list, it makes sure that that element is placed at the correct place, like where it's supposed to be, if that is what I can say, maybe in simple terms. So we start by comparing the first value, and there is a condition under insertion, is that before we carry out any iteration, only the first element belongs to the first part. So let's say maybe you have 2, 6, 5, 1, 3, 4. So for insertion, it believes that this first element is already sorted, this one. So it believes that 2 is already sorted. 6, 5, 1, 3, 4. So it believes that 2 is already sorted because it's the first, it is already sorted because it is the first element. Yeah. I think you've understood up to there. Okay. Everyone has understood. I think you people are okay there. So
Yes.
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 Somebody talked.
Yes, we got you. Can continue.
Okay. Okay. Thank you. So the insertion sort, there will be also an iteration that will be going through that list. So what will happen is that it believes that 2 is sorted, and from 6, 5, 1, 3, and 4, it believes that it's not sorted. So it picks the item that's the first element that is sorted, then it compares it to the second one. So let's say 2, 6, 5, 1, 3, 4. So I'll also use J. Okay. So it looks through the list. Then it compares the first 2. Okay. So for example, here we will compare 2 and 6. We'll compare 2 and 6. And if you get 6 is greater than 2, then it will remain the same. So I want you to understand that you look at the second element because it believes the first one is already sorted. You see? So you take this one, you compare it with the previous one. That is the goal. Like you take 6, you compare it with 2. Then if you realize that the second element is greater than the first element, it will remain the same. You'll not do anything. I hope you have understood.
But you see, it believes that so it's sorted. So
it's already sorted, but now it won't do anything to it. Then it moves. It will just move to the second. It will move now to the second. Like it will move now to the second element. Then it compares it to the previous one. So it won't do anything to these two. You won't say 2, you compare 2 to 6, you'll compare 6 to 2. I don't know if you get it.
Okay, Linda.
Yes?
Then that means it will compare, it will like from the way you are explaining the insertion sorting.
Yes.
The first element, it usually assumes that it is sorted.
Exactly.
So
It
will go to the
assumes, but
second.
it's not sorted. Like
Yeah,
it
but it's
believes,
not sorted.
yeah, it's an assumption.
Yeah, it's an
Exactly.
assumption.
Yeah.
So it will go to the next element.
Thank
and
you.
because the next element is 6, it will compare it with 2. And
Exactly.
because 6 is greater than 2, then it will assume that 6 is already sorted.
Yes.
So that means then if it goes and found out that the second element was 1, then it will compare 1 to 2. Then
Yes.
see that
Yes.
1 is less than 2.
Yes.
So like kind of sort 1. So let me move 1 to the first place, then 2 will come to where 1 was. From my
Exactly.
understanding, there you are
Exactly.
explaining.
That is it.
Okay, thank you.
Yes, that is exactly what insertion does. So when we compare 6 to 2 or 2 to 6, you realize that 6 is greater than 2. So the way he has explained, it believes the 6 is already sorted because it's already greater, so it cannot go back and interchange with the 2. 2 is small. So it will move ahead now and go to 6 and 5. You see? Then it will also compare 6 and 5. And you realize 6 is less than 5. So it will swap. You see? So let me just make it because you people will be having this notebook. So we realize 6 is greater than 2. So no swapping. So it goes ahead and compares 6 and 5. 6 and 5. Then we realize that 6 is
greater than 5.
5. So what means it will
swap?
Yeah. So it will swap. Then our list will now be 2, 6. No, 2, 5. Then 6. Then 1.
Then 1.
Then
3, 4.
4. Yeah.
Yep.
So it goes. Then we move ahead. We move again. You compare 6 to 1. You get 6 is greater than 1.
1.
Right?
Yep.
So when you get 6 is greater than 1, it will swap. But when it swaps, now that is what that one was explaining. So when it swaps, we'll have 2, 5, 6, not 6. We'll have 2, 5, 1, then 6, then
3,
then 4.
Then 4.
It won't stop there. You see, it will check 1 and 5 and realize 5 is greater than 1. So it will swap. You'll have 2, 1, then 5, then 6, then 3, then 4. Right?
Oh, yeah. Okay. Slow down there, Linda.
Okay.
Then that means after like it has gone and then it has compared like 6 and 1 and then like 6 is greater than 1. So it swaps.
Yes.
Instead of going to 3 and 4, it will like kind of go back again.
Exactly.
Okay.
Until it inserts it in the right position.
Yep.
Yeah.
So it's like inserting. What are they? Nigerians, please allow me. Hizo zenye zimeanza kwa kizungu ni nini? The whatever. Which kizungu word are we going to put there for our Nigerian brothers and sisters?
Starting word.
Exactly, you are right. That's correct. What you said is correct. Yes.
Thomas, God help you.
Yeah. So like from my understanding that it will like first of all sort those numbers that are starting on the list until it makes sure that they're good, so that it goes to those that are on the far end.
Yes.
Okay, great.
Let me put it this way. It does the opposite of bubble sort in terms of the order. For bubble sort, it puts it to the end, that is on the right hand side. While for this setting, it starts from the beginning. It arranges from the left hand side.
Yes.
Instead of bubble sort arranging it from the right hand side.
And also after arranging it on the left side, it makes sure that element is in the correct position. So see, like here, it has arranged until 1 is here. It will go on to compare 1 and 2. So it will continue until 1 goes to the right. It is inserted in the right position. Then after it finishes, it will go back to where now it left, where it was. Then it goes now to to the next element. So for example, here we see after we compared, where was it? We compared, was it? I can't remember, but we moved.
Yeah,
this
we compared, where did we compare? We compared 6 and, 1 and 6.
Yeah, 1 and 6. So you see that one came here. We swapped because 6 was greater than 1. Then after we swapped, it went and compared with 5. It realized 5 is greater than 1. It swapped.
Yep.
Then it went ahead again and compared 1 and 2, and it realized 2 is greater than 1. Then it swapped. So after here, it will go back to 6. You see? Then 6, it will compare with 3.
Where it
You
left
see?
off. Yeah, exactly.
Are you okay?
Yeah.
Okay, so it compares 6 to 3. Then you realize 6 is greater than 3. So it will swap so that 3 comes back. So it will be, it will swap so that 3 comes here. Then it compare 3 to 5 and realize 5 is greater than 3. It will swap. Then it compare 3 and 2 and realize 2 is less than 3. So it leaves it there because it believes 3 is at the right position. So it will be 1, 2, 3, then 5, then 6, then 4. Then it goes 6 and 4.
Linda.
Yes?
Linda, I just hope that guys have understood there's a step there that you have jumped.
Yes, I have.
Yeah, I hope guys have understood that. There's a step there that you have jumped.
Let's write it in correct way, please, so that it's
okay.
So 3, 1, 2, 5, 3, 6. First,
So can I just get rid of this?
Yeah, just do 1.
Okay. So we can't
Just repeat that step.
We
Please repeat that step.
I can't hear you, PG.
You're saying repeat that step where you swapped 3 with like a
with 6. So 6 compares to 3. You realize 6 is greater than 3. So that means if it's greater than 3, it should be in front of 3. So 3 should go behind of 6. So that will be 1, 2, 5, then 3, then 6, then 4. But you realize 3 when it comes here, the insertion, the iteration will now compare 3 to 5. You see? Then it realizes that 5 is greater than 3. So 3 goes behind 5 because it's small. Then you go to 3, then 5, then 6, then 4, right? So here should be 4.
Yeah, 4.
Yeah. Then it goes 3 and 2. Is 3 greater than 2?
No. The last one.
4 are the last one.
4. Yeah.
Okay, thank you. So then it reaches here now 3 is here. 3 compares with the 2. Is 3 greater than 2?
Yes.
Yeah, 3 is greater than 2.
So that means it can't go beyond 2. See, that's true.
Yep.
So the insertion iteration believes that 3 is at the right position. It has inserted 3 at the right position. Then it goes. Now we have remained 6 and 4. It compares 6 and 4. Is 6 greater than 4? Yes. So
Yes,
that means 4 goes behind what? Goes behind 6. Yes. Then it compares now 4 to 5. 4 and 5. Is 5 greater than 4? Yes. So it goes behind 5. Then it goes now to 4 and 3. Is 4 greater than 3? Yes.
Yeah.
So it cannot be behind 3. So it finishes and it now the list is sorted. Yeah. So that is how insertion does.
Okay.
Yeah.
So just going through this, it now seems like insertion it takes a longer route than the bubble sort. It takes a longer time than the bubble sort.
Does it? Can somebody clarify that?
Actually, I feel like bubble sort takes long.
I think it's faster than bubble. That bubble one is just too long.
Because the complexity, the worst case complexity of insertion is O(n) squared. And let's see the bubble. Just a minute.
So Linda.
Yes.
The logic behind insertion in this, what I've just done is like when it now starts sorting.
Yes.
Then it goes ahead, and then when it reaches somewhere and then sorts something.
Yes.
Then it quickly realizes that okay, there's something that needs to be sorted back again. So it goes back again. Then sort. If it realizes that there's something that needs to be sorted again at the back, it goes back again until it finishes so that it continues. That is
yeah. So just to explain for you, like in an easier way, the goal of insertion is to make sure that the element is at the right place. So despite swapping and moving, like you've swapped, it goes ahead and compares with the adjacent, like for example, if we were swapping 4 and 6, and then 4 comes back, then it goes ahead and compares it to the element that is behind it. Like, is it behind? Yes, it's behind it. You see, just to make sure that it's at the right, like it has inserted it at the right place. Then when it realizes that it's not at the right place, then it goes ahead and when it reaches to that, when it swaps and goes to that, it makes sure it compares with the element behind, just to make sure that is that 3 at the right position. Then when it realizes it's at the right position, then it stops there. It inserts the element there, then goes back to the list where it had left there. It had left, then checks if there's any other thing that needs to be sorted. So it does that until the entire list is sorted correctly. Then it stops. Yeah.
Yeah, okay, thank you so much. That explanation is very good. I've understood it now clearly.
Okay, thank you.
You're welcome.
Any other person who is having problems?
The concept is well understood. Even the bubble concept is well understood. The problem comes when now the J's and I's start coming.
When you are deploying, not deploying, implementing. Sorry. Yeah, but the reason. Okay, there's something. Okay, Thomas.
But it's way better than some.
PG, I haven't got what you've said.
I'm saying because it's way better than it's the note one. One.
Yeah. Okay, and Thomas, what were you saying?
No, I'm okay. I've gotten what I wanted.
Okay. Anthony, I saw you've admitted yourself.
No, I wanted to just correct Thomas that was not Neymar. That was somebody else.
Okay.
God, I beg. Your voice is not the same.
They're the same, yeah. Actually, it's something that you need to understand is that if you understand it that way, like the way it's moving, you see, even if you are not able to implement the algorithm now, but in your mind, you know what the insertion sort does when it goes through the list. Believe me not, when you practice it 3 to 4 times, maybe let's say 3 to 4 times, maybe this week you practice twice, next week you practice twice. The other week you'll be writing it by yourself because you'll be understanding what is happening. But for the first time, you'll not catch it, but at least because you've known what is happening, you'll be understanding what the code is doing, even if it's not 100% to what you want it to do. So believe me not, after some time, when you practice, like right now we've done it, then maybe after 2 days you go back and maybe practice bubble sort, and then you'll be writing the code very, 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 very well. Yeah. But if you don't understand it, like the way the numbers are moving, then you won't even be able to understand the algorithm, because you'll be wondering, why are we adding 1? Why are we doing this? Why is it J minus 2? Yeah. But all in all of us are now at the right place. Like how do I say? We are on the right.
We are at par.
Yes, we are at par. Yeah. So don't be worried with the algorithm. It's something like coding needs you practice. Yeah. Then you've understood it very well. So let's try implementing it. We'll help each other. I believe that's good. So let's define insertion. Then my list. So what happens? What was the first thing that was happening? If you can remember.
And 2 is assumed to be in the right position.
Pardon?
2 is assumed to be in the right position.
Yes, and then after it is assumed, what happens with the insertion algorithm? It iterates through
Yes.
it goes as it compares, right? So we
Yes.
have for I in range. So here there will be a slight difference. It assumes what the is it, how do we call? It assumes that 2 is already sorted, or the first element is sorted. So that's why we have 1 there. If somebody will ask me why 1 is there, this is because the loop starts at position number 1 and goes until the end of the list. When you say the loop starts at position number 1, that means that it assumes this one is already sorted, which is at index 0, then it starts at index 1. Are we together?
Yes.
Okay. So then now after that, after it assumes that, then after it starts at index 1, then it iterates now through the length of our list.
And Linda, you have left space between len brackets my.
Thank you.
Yeah. And even on our insertion function, we did the same.
I need to do this?
No. Insertion then space. Yep.
Okay, yeah.
And then on the word len.
Yeah.
Yep.
Thank you so much for that.
You're welcome.
Okay. After there, we need to help. We are helping each other one by one. After it iterates, what does it do? Any person?
It checks if there is anyone that is greater than, then swap or not swap.
Okay. So we can say maybe if j is equals to I, then while j minus 1 is greater than here should be my list.
Now, Linda.
Yes.
This is what PG was saying.
Yes.
Explanation up there, we understand. Now it comes to J and I.
Okay.
Sadness.
So let's do this. So this was our J. This one, right? See, we said we assume this one is the. I want to be together with you. We assume this one is already sorted, so we'll start at position number 1. So this one is our J. Let me say this one is our J. So will you compare it to J plus 1, or you compare it to J minus 1, the previous?
J minus 1.
Exactly. And if you get the J minus 1 is greater than the list, like you see, like you are telling the algorithm, like if it checks that and this condition is true, then we will swap. You see.
Mm-hmm.
So that means if J minus 1 is greater than J, what happens? Do you swap or you leave it like that?
It swaps.
You leave. Or if there is any other person who can explain it differently?
You think if J minus 1 is greater than?
If J minus 1 is greater than J, what happens? So we need to know what is our J, right? So that is what we need to do. What is our J?
You've just told us that our J is the second value where it will start, because insertion function assumes that the first value is sorted. So our J will be like the second value in that list.
Will it not be the first one? I'm trying to see if I'm confusing. Just a minute. Let me just look somewhere to be sure.
Okay. So,
Or somebody,
Linda, I have a
so if somebody
question.
else knows what our J minus, just a minute. Okay.
Linda,
Is
instead
somebody
of,
else talking?
yes, I want to ask a question.
Yes.
We are using J now to represent these our numbers.
Yes.
So why not we just use J and J minus 1? Why introduce I again? I think that's where the problem is coming. If we just use J and J minus 1, we know that J is 6, J minus 1 2, and then J plus 1 is 5, just like something like that. So we know that we don't need I again. So why the I? Why did we come about I?
We need I.
I believe
I is any number.
Yeah.
Okay, okay, I
If J
get
is
you
the
now.
first one, the second one is J plus 1. I is any number in the list.
Okay, thank you. It's clear now. Thank you.
Okay. So there's something that I want us to be on the same page. I want us to know like where which one is J and which one is J minus 1, so that we can compare and know. So I believe this one is the 2 is the J, or is 6 the J? Can you help me? We are doing this from like everyone, so that everyone knows what is happening. Because I don't want just to write. I don't want to write. Then we don't know what is happening.
Okay, if we are using J minus 1 in our while loop,
yes,
that means J should be 6, so that J minus 1 can have a place of 2.
So J minus 1 is 6, right?
No, 2.
No, Thomas.
Yes, please, Ibarra.
Yeah, when you say right. J minus 1 is, I'm not getting that thing.
Okay, can you explain again, Thomas? Let me do this. Let me do this. Let me do this. Just a minute. Let me do this. Let me just bring here just as a placeholder. Okay. Thomas, can you explain?
Okay, the way I understood it.
Yes.
Just like we are talking about the number, the index number, that the first number is 0. Is that okay?
Yes.
Okay. So if the first number is 0, what is the second number? 1.
1. Right? Yes.
So if 1 represents J, what would be 2, which is the first number? 1 minus 1. That will give you 0.
Yes.
Which goes back to the first number. So if we are saying J is 6, then J minus 1 should be 2. Am I confusing you?
No, you're not confusing.
How did you arrive at J being 6?
Yeah, that was my question too. Yeah.
Okay, me too. I followed what Linda said, that J was 6. I didn't bring that one. So if we assume that her J is 6, then J minus 1 should be 2. And I is any number.
And you don't, and let me tell you something, you don't need even, I just want us to reason to be on the same page. We don't need even to say J minus 1 or something. Even another person can say J plus 1. But maybe I just want us to understand like which one will be our J and which one maybe if you're moving on the right, which one will be our J plus 1, something of the sort. That is just what I want us to understand. Because we can go differently. Yes.
How do you write the shift now after that while? How do you shift them? You write what is equal to what?
Yes, you shift. So you see. Oh, sorry. So you'll shift this one. Maybe if it gets this one is greater than this, you'll shift it. So you'll write it as list J minus 1, comma list J is equals to list J comma list j minus 1.
Okay, write it, please. I see.
Please comment it.
I will. We are still trying to figure out my list. So it will be j minus 1, then comma, list j, then is equals to, now this one becomes, this one will be my list, then this one will be, so it will swap. So
Yeah, that one will be my list J.
my list j, then comma,
my list
my list
J minus 1.
yes, j minus 1. So that is what will happen. So the question I'm asking is that I want us to know if j, because it checks this j is equals to I is the one that is helping us to check if we need to do swaps or not. This one, while my list, then j minus 1 is greater than my list j. You see, that is what will help us to see if we'll swap it or not. So I wanted to know if our j minus 1, is it this 6 or it's 2? That is what I wanted to know. If we get that, then we'll go ahead.
From that, while my list j minus 1 is greater than
my list
j, from the way I look at it, I believe that j minus 1 is 6.
Yes.
So that if 6 is greater than my list j and j is 2.
Yes.
Then
I think it's the opposite, right?
No, Ibrahim, you have swapped the stuff. Oh.
It's the opposite.
You have swapped it.
Okay,
I want to understand.
So let's say our 6 is j minus 1 and our 2 is j. So that means if 6 is greater than 2, we swap, which doesn't make sense, right?
Yeah, exactly.
But if we say this one is j minus 1, then this one is j, like it compares with the previous one. Then this one is j. That means that if 6 is greater than, if j minus 1 is greater than j, we swap. And here we realize that j minus 1 is not greater than j. So we leave it that way. So this j moves to 5, right? Then this j minus 1 moves to here.
Hello.
Yes?
Hello.
Yes?
But we said that this insertion sorting assumes that 2 is already sorted.
Yes, that's why.
Why are we still so? This part is confusing. When you say
okay, sorry.
So then why is it swapping if it assumes 2 is already sorted? Does that even make sense in this context? Because then we are still swapping anyway.
Okay, you see the reason why even it assumes, it's not that it believes, like not even it believes, like it's not sure. You see, it's not sure if that list, if that 2 is sorted, it assumes, it's an assumption. Then after assuming, it will not touch it and compare it with anything. It will go to the next element that is in that list. Now it will compare it now to that element that it assumed it is sorted, just to make sure that it is sorted. Because at the end of the day, even after it assumed that 2 was sorted, after iterating, we realized that there was a 1, which is less than 2. You see? So the only goal is that it assumes, but when it moves one step ahead, it compares it with the previous, like the number behind it. You see?
Okay.
So j is I minus 1.
Yeah.
J is I
because
minus
it's
1.
behind. Because it's behind. And this j, if you go ahead, it will be, if we were comparing with the ones on the right, I think it will be j plus 1 for me. That is how
exactly.
But because it's compared it to the previous, like the number behind, then this will be j minus 1. So let's, for example, so I wanted us to see which one will be our j minus 1 and which one will be our j. So for example, when you come here, j minus 1 here now becomes 6. Then j becomes 5. Then you realize that j minus 1 indeed is greater than j. So here we swap. I don't know if you are getting it.
Excuse,
Okay.
Linda.
Yes.
I think your explanation is contradicting the assumption you said. You've said that 2 is assumed to be
in
the right place.
Yes.
So for it, 2 is j, right?
Yes.
So if j minus 1, so the first j will be 6.
Okay.
Not 2.
Okay, let me do this. Yeah, it's the same thing.
Minus 1.
It's the same thing. Okay,
It is assuming. Listen, it is assuming that 2 is already sorted.
Yes.
So the first element will be j.
Yes.
So it will be 6.
Yes.
6 will be the one that will be j.
Okay.
So it is assuming that 2 is already sorted. The first element will be j, and it will be 6.
Yes.
So 6 minus 1, j minus 1
will be 2. Yes.
So if j minus 1 is greater than
j,
you swap.
No.
Yes, he's right.
Then you don't
He's
swap.
right.
So it's
He's
fine.
right.
So the question is, why are we saying j is equals to I?
So let me answer that.
I minus 1.
Okay, j is equals to 1 because that is, I think that is where it started. We started that j is equals to 2, right?
We saying j is equals to I.
Okay, can somebody who is understanding it explain? Let's help each other.
Let me explain that.
Yeah.
Our starting point is the second index. So we are saying for every element in the range of index 1, not index 0, index 1, then the length of my list. For every element in the range of my list, starting from index 1, that is number 6. If you said from every element in range of my list now, removing that 1, it will just say, it will just count the whole thing, starting from like this index 0 to the end of the list. So we are saying for every element in the range of my list from the first index, that is not index 0 now, index 1.
Yes.
Index 1 to the length of that list. Now, j will be equal to I, that is what equal to that element.
Exactly.
J will be equal to that index 1. So which is number 6 in our example.
Yes.
So while j minus 1, that is while 2 is greater than j, do the following do the following operation. I've not really gone through that our operation. That is, if it's less than, if greater than, swap. So that's just the function of that j equals to I.
Yeah, actually, he's right. Did somebody get what he said? He's very right, because the reason why I just got from the page. The reason why j is equating to 1, it's because, remember, you are saying our j is starting from 6. And 6 is our first position. You see? 6 is our first position. So j is equals to I. It will pick the first, like it equates j, the first one, is equals to the I, the first one. So that's why that is a condition that we need to make. You see, for it to work. That is what he was explaining. And that makes sense.
Okay, try running it then.
No, we've not finished it.
We have not running it yet.
Yeah, we've not finished it. There is a condition. There's a condition that we need to add here. Because we've said, while my list j minus 1 is greater than my list j, but we have another condition. J should be greater than 0 because we are starting at the first position, like the element 1. So also this condition should be satisfied. J should be greater than 0. Then if this condition is satisfied, then now it swaps. Yeah. Are you people there?
Yes, we are here.
Yes. So the condition of J is greater than 1 needs to be there, because when it's iterating, it makes sure that our J is greater than 0. Then my list J minus 1 is greater than my list J. Then if that condition is fulfilled, it should work. There's no need of even, how do we call it? There's no need of even saying return this or return that. But another thing that we need to add is that we need to add is it increment or decrement? Like J is decrementing. So you need to say J is decrementing. So from there, I think it will work, because now it's going, while it, like J is going as it changes positions until it will go back to J will go back to where it's supposed to be. Yeah.
Linda, I have a question. You've said for I in range 1,
Yes.
1, then length of
Length
my
of list.
Okay. But now this J is 1. So it is greater or equal to 0, it's greater than 1. Like the condition you've given there, J is greater than 0.
This one.
Okay, can I explain, Jolene?
Yes, please.
You see, while my list J minus 1 is greater than my list J, that means for us to make sure that J starts at position 1, that is according to the way we index it, the way we do indexing in Python, 0, 1. Then J should be greater than 0. From my understanding, from what you wrote, Linda.
Okay.
J should be greater than 0, so that the second element in that list will be J. I don't know if you're getting me. Because if you just like leave it like that, maybe Python can just assume that J is the element at index 0, so J will be 2, but we want J to be 6, like the second element. I don't know if I have explained something. Python is hard.
Linda, which tribe are you? Sorry.
I'll tell
She's
you
from
who asked
Nigeria.
that question. It was Fiji. Jolly.
She's from Nigeria and Cross River State.
I'll tell you, Jolene.
Someone is looking for a wife.
So you understand why it's decrementing the J minus is equals to 1. It decrements because J, it moves to the previous position. So I don't know if you people have understood, or because that is what we were doing everywhere until we sorted the list.
Linda,
yes?
Could you repeat what you said? For the
I'm saying
yes.
The decrement, it decrements J to move to the previous position, this part. And if it could be plus, it could increment J to move to now it will be the next position, because now it will be moving like you're moving to the right. But this time round, we are moving it like we are sorting when we go to the left side. Yeah. But I think before I run, everybody should be has understood this code. So if you have any problem, just say so that we do it before we run it. Because if we look at the first thing, we took the function insertion, Then we iterate, the outer loop iterates through the range, and it starts from, we said we cannot, it assumes 2 is the first one. So we place 1, meaning that it starts from the index 1 of that, like position 1 of our code. Then it iterates through each element of the list. Then it checks if my list j minus 1 is greater than my list j, and whether j is greater than 0. If both conditions become true, then it swaps. And when it's swapped, j is it decrements. That is what me have understood. So I don't know if you people or anyone who has a better version of it, they can tell us, because I think this code can be written in many different ways.
Let's run it. We are with you.
Okay, so how we need to place there. So we can say my list. Which was our list? Let me pick this one that we used.
Lean. What about lean, my list?
Where?
Are you not supposed to put lean at my list? Yes, where your cursor is blinking.
I need to
put lean, L-E-N.
Len.
Are we not supposed to include it here? Yes.
I don't think so.
Yeah,
but
me
let's
too.
start to investigate it. Because here we are just want to like print.
Yeah, that's what it was.
Linda.
What if we just do
Linda.
this?
Linda.
Yeah? Yes.
On our function, did we
Yes.
require a return after J, after is it decrementing or what is it? English is also hard.
Yeah, we need to return my list.
Yeah, because it's a function, right?
Yeah.
Yeah, I think we need that.
So you're just doing research and you're wasting my time and you're wasting other people's time as well that could have been applying for this role.
So same like how you are wasting my time when you clearly knew that I was overqualified.
It's doing the things it was doing. 265. It has not done it.
You see, like we have not like created a variable known as my list.
Okay, yeah. So
I make the final decision in this company.
Yes, sir. Just like my parent.
What do you mean, just like your parent?
My parent tells exactly what it has to tell because I train my parent what to tell. Same way your CEO
that way.
Yep.
Then
we print or we call that insertion function.
when the final decision comes.
Russian President Vladimir Putin recently held an end-of-year marathon press conference to answer the most burning questions from Russian citizens, as well as both foreign and local.
not yet. That means we have a problem here.
On the function.
Yes.
Putin said that Russia's economy has been remarkably resilient in the face of Western sanctions, noting that the GDP was expected to grow by more than 3% by the end of the year, with the real income set to increase by 1%.
Anyone is seeing any problem?
Chat ChatGPT says our while is not properly indented
I think the one that is
inside the for loop. Yeah.
so while should move ahead like that.
Yes. Yes.
Yes, that works. So it was indentation. Yeah.
Yep.
It worked. It means the return list was returning the while. But you see, if you return my list, that means if this condition is not met, that means it returns my list, and then the iteration goes again. And goes again, it does, and then if it finds it's not, then again it returns my list and iterates until now the list is sorted. Yeah. But this is the easiest way of writing the insertion iteration. But another person you can write it in different ways and it will still work. Yeah.
Linda, can you kindly just remind me what J equals to I what does it means there in that function? Because at least I've understood. Otherwise, it's giving me a challenge.
So let's bring here so we said it assumes this one is it assumes this one is already sorted. So it begins from value number, then not value number 1, the element at position 1, right?
Yep.
So we've said our element at position 1 will be our J, right?
Yes.
So our element at position 1, if it's J, that means that it will compare it to the previous one. And if it compares to the previous one, what means what will be the previous? It will be J minus 1.
Yeah. J
so this one will be J minus 1, right? So you go ahead and now come and check this loop. You say, well, my list J minus 1. So you look at J minus 1.
No. I'm not talking about that one.
Yeah.
I'm talking about J equals to I.
J equals to I.
Yeah, up there before I.
This one.
Yeah.
There's a person who explained it very well. Who was that?
I think Thomas.
Yes, Thomas, can you explain it to them again? This J is equals to 1.
Okay, according to what we agreed, not me. That
fine. Fine.
That the I, J equals to I means J can take the place of any number as the iteration takes on. Like as you start iteration now, J can swap to 5, can swap to 1, can swap to 3, can swap to 5, and carry out the iteration as you want it to be, while my list J minus 1 is greater than my list J. If it doesn't take any number at any time, that means the iteration will not continue.
Okay. And also maybe to add on what Thomas has said. You see, if you say J is equals to 1, this is something that we've introduced in the algorithm so that it can help us to keep track of the current position. Like the algorithm is keeping track of our current position. So let's say we are at 6. 6 is our J, right? So the algorithm is keeping track and equating the J is equals to 1, which means that it initializes the variable J with the current index I. And the reason for this is that it wants to keep track of the position of the current element being considered now to be executed. So that's why we are equating J is equals to 1.
Linda.
Yes?
Can I just ask this? The way I'm reading the code,
yes,
what I read here is that while I is carrying out the iteration,
yes,
then we are saying, when we say J is equal to I here,
yes,
we are saying that the index position,
yes,
which I is checking, is equal to the value of, yes, equal to the value J, which is the value, the element in the list itself.
Exactly, yeah. And also something also to add on that so that people understand it very well. We have said that insertion, it assumes the first one, right? It believes that it's an assumption. It believes that in our position 2 is sorted, right? So it goes to 6 and 6 is J. So if we start running our for loop, where will it start iterating from? Can somebody tell me where will it start iterating from? Will it start iterating from 2 or will it start iterating from 6? Anyone?
Can you ask the question again? Ask the question again.
I'm asking. We have 2, 6, 5, 1, 3, 4. So we've said the major assumption in insertion is that the first element is assumed to be sorted. That means our iteration starts to the next element after the first element, which is 6. And 6, we are placing it to be our position J. Then my question is, because the outer loop we've said for I in range, then position 1 length my list, where will it start iterating from?
From 6.
And what is 6? What is 6? Will be the first I element. So that is why J is equals to 1.
So Linda, you're saying that J is not in its current position. It's on
J is in its current position. Let's say, okay, what do I do? Let me remove this J minus 1, right? So we've said the J will be at 6, right? Like, is it correct?
Yes.
Okay.
Yes,
so what our first ith term will be at? Like when it starts iterating, it will start from the J, right?
Yes.
So that means anytime J moves to the right, that element that J is on its position, that is where the iteration will start. The next iteration will start. Then when J moves again, the for loop will iterate again like that. When J moves, so it means that if J moves, the iteration moves the I. So the J element is equated to I just to keep track of the iteration. That is what I think I've understood with that. So I don't know if
I have a concern, guys.
Yes.
Yeah, that makes sense. Concern.
Yes.
I have a concern, not to return you guys behind, but
no problem. Yes.
Not in every normal case you'll find that the first number is less than, like it will already have started the sorting. So I just want you to kindly interchange. Maybe start with an 8 there instead of 2.
Okay.
And then 8, 2, 6, and then we see how this forever is assuming the first, because I don't think that the first.
So you said that there 8, right?
Yes.
Okay, so it assumes
maybe 8, 9, then 2, 1.
Okay, so 8, 9, then 2. Okay. So we said I step there.
Remove the stroke. So maybe this is my list, right? And I want to do it with the insertion method.
Okay. So the first thing we've said, it assumes the first element is sorted, right? Who was talking?
Jolene, just
I want us to I want to converse with you. So we believe that the first element 8 is sorted, right? So what happens?
So what I've understood the explanation, but I just want you to write like my list is equal to this, the one I've given you. Then insertion my list, you run it. I just want to see the output.
Okay, it's okay. I've understood.
It will still sort it actually.
I think you are saying that you wanted to see how it will insert. Oh, I'm so sorry. What happened?
I think also we remove 9 so we can have 2 being less than 8.
Oh, yeah.
He's having 2 lists, so he cannot work. Rather, add something.
Okay, this one is the list 1.
Yes.
And then this one will be list 2. Let me do this. No, it's still not working.
No, reduce one of the brackets.
You underlined
There are
it by
two
mistake. You
brackets.
can pick whatever you have and add an 8 before. Just pick the old cell, copy paste it, and add an 8 before.
Linda?
Yes?
And then you can change it. It's a markdown.
Oh, thank you. Yeah, exactly. I was so worried. Thank you so much. Yeah.
And also, Linda, I think it's the same thing. So you need to
Remove. Can Linda, before you run it, kindly remove that 8. I want 9 too.
Yes.
So that just what happened. Yes, maybe like that.
So should I still call it my list? Yeah.
That's okay. It won't affect anything.
Yes.
You can still call it your list. It will still sort it, Jolene.
Yeah, I think so. Yeah.
It will only jump one number in 1, 2, 3, 4.
It sorted it.
Yes, 1, 2, 3, 4, 5, 6, and 9.
Okay. Because it will compare every time, and then if it finds that it's greater than, then it swaps.
Yeah.
After assuming, like what I think I was answered when I asked the first time, that doesn't mean that it won't sort it. Just assumes and starts with the next number.
Yeah, like even after it has, yes, you are right, because it just assumes, but at the end of the day, it will sort it because it will realize it's at the wrong position. So it doesn't that assume, then it leave it there such that 9 will just stay there. It will leave it there just to assume.
Yeah, so that explains to the guys who are asking what is J and I. So you just see it's any number. It's not that fixed.
Yeah.